Welcome to the Plant Engineering Webcast, Principles of Lean Maintenance. I'm your moderator, Bob Vavra, and I'll be happy to join you today on behalf of Plant Engineering. I'm now very happy to introduce our distinguished speaker, good friend, and a guy who's really going to bring a lot of insight for you on this presentation today, Sean Eisenhower, Director of Education for Allied Reliability Group. Sean specializes in business process management, strategic planning, organizational change management, and reliability engineering, and has led improvement initiatives in a variety of industries, including pharmaceuticals, metals, petrochemical, paper, and power generation. He's an engineering graduate of North Carolina State University and has become an expert on the implementation of holistic reliability solutions using tools such as total productive maintenance, reliability-centered maintenance, and root cause analysis, as well as Six Sigma and Lean to drive significant bottom-line results. Sean's currently serving as the past chairman of the National Board and is a past director of education for the Society of Maintenance and Reliability Professionals. He's also a past committee vice chair in the area of benchmarking. He's a certified maintenance and reliability personnel and has been certified by ProC and Colorado State University as a change management professional. He was a 2010 Plant Engineering Future 30 honoree and 2011-2013 U.S. Science and Engineering Festival Nifty 50 speaker, as well as being the recipient of the Solution Magazine Best Article Award for 2010, and really outside the Oscars and the Emmys, those are the ones you want to win. Our congratulations on all of those to Sean. We're looking forward to today's presentation. Sean, good afternoon and welcome.
Thank you, Bob. Looking forward to the presentation today. Today we're going to talk a little bit about lean maintenance and reliability. And really the key here is it's all about increasing flow and reducing waste. So as we go through the slides today, we'll try to hit many of the learning points that you saw earlier, as well as a few more that I'll share with you here in a few minutes. So again, my name is Sean Eisenhower, and if you'd like to see more information, you can also go to my blog at www.reliabilitynow.com and see other topics on this very subject. So we'll go ahead and advance to the next slide. So our topics today, we're going to look at the evolution of Lean. We're going to look at where it came from, who was involved as it went through that process. This helps actually quite a bit because once you really understand where Lean came from, you start to understand who contributed. You can begin to study those individual contributors and see how it all fits together when we talk about Lean maintenance. The next thing that we'll talk about is the heart of Lean and a few key concepts. We're going to take a look at 5F. We're going to take a look at MUDA. We're going to take a look at the Kaizen approach, Poka-yoke, and then I'm going to finish up with overall Lean objectives and how you might take them into implementation within your facility. On the next slide, we'll start with the evolution of Lean. So the first person that we see that really started to think about the evolution of Lean was Benjamin Franklin. Benjamin Franklin was looking at how can we increase profits without increasing revenue. So the next person that was then involved as we move forward was Eli Whitney. And Eli Whitney started thinking about the idea of the concept of interchangeable parts. He was looking at the assembly lines that assembled rifles and trying to make them more efficient. So you see, we started very early with one of the founders of the country, and then moving into Eli Whitney. And from there, we moved into Frederick Taylor. Frederick Taylor was looking at the idea of standardized work and time studies, another component that you'll hear many people talk about when they talk about Lean implementation. The next person that we'll talk about is Frank Gilbreth, and he looked at process charts and motion studies. So you start to see some of these folks coming together, building those core processes that became what is known as Lean today. Now, Henry Ford took the work of many of the folks that we just talked about, as well as others, and he started to build a process. And that process was all about the manufacturing strategy. He has two books, two very good books that you might check out. They're shown there on the screen. And as he moved through that, he started to convey his passion for eliminating waste. Specifically for Henry Ford, it was wasted time. And we'll move on to the next slide, where we'll talk a little bit about Edward Deming. So many of you probably have heard of Edward Deming. He's one of the fathers of total quality management. And We also have Duran, who was one of the fathers of statistical process control. So these two individuals started to take some of the work that Ford had started and begin to perfect that moving forward. Now, as we move into the Toyota side of the story, which many people know of Lean as being something that was generated out of the Toyota production system, but interestingly enough, many of the concepts came from the folks you saw in the last few slides. So as we move into the Toyota story, we see that they studied Ford Motor Company and Toyota, while at the helm of EG Toyota, actually began to move Toyota into profitability. Now on the next slide, we see another person that gets mentioned many times when we talk about Lean, and this is Toyota's chief engineer. He also studied at Ford Motor Company, and his name is Teiichi Ono. So each one of these individuals that we've talked about here, they all have books available that you can begin to look at and study and learn more and more about the genesis of Lean moving forward. And we're going to move on to the next slide, and in here you're going to see Shingo, and he was one of the, again, another one of the consulting engineers to Toyota, but he developed the Poka yoke and the single-minute exchange of dies. So he added that piece to what then became the Toyota production system and moved into what we know of as Lean today. So a little bit of the history. I think you see some of the concepts there. Now what I want to do is take you into this next slide where we talk a little bit about the tools. So, you know, many people I hear, they're implementing Lean, they're implementing RCM, they're implementing many other initiatives, and they really just want to understand, you know, how does all this fit together? Or a comment I hear more often than not, I can't do reliability because I'm doing Lean. I'm too busy. Well, the point I want to make as we go through the presentation today is these tools that we talk about as Lean tools or Lean maintenance tools, they are very much similar. You'll see many connections as we go through, so you can use those Lean tools that you've developed in order to attack your reliability and maintenance problems, hence the idea of Lean maintenance. Now we'll move on to the next slide where I talk a little bit about the unification theory. And this is really the point here. The point is that if you look, when you really study all the things that exist, many of the best practices apply across multiple industries, multiple areas, and that's exactly what we see here. So when you look at Lean, you look at reliability, you look at Six Sigma, again, the tools that you use in each of those are very supportive and apply in all of the areas. Now we'll move on to the next slide where we talk a little bit about the heart of Lean. So you see a graphic on your screen, and here we're looking at that cycle as we go through Lean. Now the first thing that I'm going to talk about is Mura, and Mura is an undesirable condition that's found within the system. So the next area you see is Muri, and this is a condition that led to extra work or extra effort. Then Muda, that's the extra work that is wasted effort and must be eliminated. And through Hansei, we can start talking about accountability for removing that error and taking responsibility for the implementation of the correction. And then Kaizen, which is our idea of being able to prevent that reoccurrence and continuously improve as we move forward. And Yokoten, which is spreading that information out to the rest of the organization. So this is that cycle. This is what becomes the heart of Lean as we move forward. So we want to look for the undesirable conditions. We want to identify that extra work that those conditions are generating. We want to then move through and eliminate that extra work and then communicate that out to the larger organization going forward as we move through this process. Now we'll move on to the next slide, and what I'm going to do is let the video play, and this is going to explain a little bit of the connection between Lean and reliability and operational excellence. All right, we'll start the video now.
My name is Darren Wyckoff, and in this video I'm going to use the Lean House model to illustrate how maintenance, reliability, and operational improvement fits together within operational excellence. We're going to start our discussion at the top of our Lean House model, and really what is the overall objective of operational excellence is to improve the financial health of the business. We're using return on assets as the comparator between business to really look at how well is your organization using its assets to generate revenue. There are two pillars in every Lean House model. Hey, the first pillar that we're looking at is increasing flow. As we increase the volume of product through the value stream, we should increase revenues. And the second pillar would be then eliminating the waste. Eliminating the waste allows us to reduce the cost of production. Right? Revenue minus cost gives us a net income value, which is the numerator in the return on assets calculation. So now we have to bring in the denominator, and that's our asset base. How well is your organization generating that net income based on its average asset value within a fiscal period? Our lean house isn't done yet. Here's where most people stop, but we're going to build a foundation. We're going to create some stability for that operational improvement. Allow you to accelerate your rate of increasing flow and eliminating the waste by adding 3 more components. The first cornerstone that we're going to add to our foundation is reliability. Reliability is very simply, what is that average duration of time between performance losses, between downtimes, between breakdowns, between failures, coupled with our other cornerstone, which is maintainability. After your organization experiences a loss, it's not getting that product volume through the value stream, how long does it take you to recover? And in this, we're talking about the maintenance process from the point where work is initiated, the time it takes to plan and schedule, the time it takes to obtain those materials, and finally the time it actually takes to execute the work. If we improve reliability, if we improve maintainability, then what we in fact increase is availability, which is the third piece of our foundation. The more the assets are available for full production, for good production, the more volume you get through the process. The more maintainable they are, the quicker we are at restoring to full capacity or full operational specification, the less waste we should have, the less cost that we should have. I hope I've illustrated how maintenance, reliability, and operational improvement all fit together in that operational excellence context. If you'd like to learn more, please go back to ibltraining.com.
Okay, so we heard from Darren Wyckoff, and he shared a little bit about how lean connects into those overall operational excellence goals. And I think that's key. As engineers or maintenance folks, as we look at lean, we need to be understanding how does this fit into the business objectives of the organization. And, if you're trying to improve your reliability, if you can tie it into these terms, it's going to be much more supported by the overall operations. And that's really what we're looking for to drive the implementation forward. So next we're gonna look quickly at the model that Darren talked about in the video. I've added a couple more details into this one just so you can see a little more about what's going on. But there's some key points here. If you're looking at lean is going to be very much focused on flow, going to be very much focused on waste. Six Sigma can also be used in both areas really to help to improve each of those. So we want to, as you can see from the red arrow, lower that waste. We want to increase the flow or the throughput of the facility. That's going to increase our revenue, and by lowering the waste, that's going to decrease our cost. So that gives us that return on net assets. So we've got a few things down in the bottom there, and I wanted to point those out. I've pointed out, or I've added in, reliability-centered maintenance and asset health management, and equipment maintenance plans. Some of the key foundations for building lean maintenance into your reliability model. We'll move on to the next slide. So these are the 8 wastes of lean maintenance and reliability, and we put them in under the acronym downtime. That'll help everyone remember them going forward. So I'm going to read them off to you. Defects impacting asset health. And for us, asset health is all about, is the asset healthy? Does it have defects that have been identified through your predictive maintenance program? Or are there any issues that might come up moving forward? Now, that's the defect. So anytime you see us moving through the asset health piece, that's what we're referring to. It's about having an asset that is ready to perform the duty that you have day in and day out. The second thing that you see as a waste is overtime. Of course, there's always a certain amount of overtime in every business. I've seen a few studies that say it's somewhere between 10 and 12% here in the U.S. But if you have excessive, if you have more than that moving forward, then you may indeed either be understaffed or overworked, and that can be due to efficiency issues or others. The next one that you see there is work execution delays. So I know that many of you in your facilities, you have your maintenance folks move out into the floor. They may be out there to do a repair, but unfortunately at that point operations isn't ready for them, maybe because of a communications issue, maybe a production goal has changed, but something has occurred there in our planning and scheduling process that has led to that work execution delay. The next area you see, the N in downtime, is non-value added preventive maintenance tasks. We see a lot of these. I call them pregnant PMs. These are those PMs that we keep adding tasks to over time. We've added detail, we've had a failure somewhere in the past, and someone just decided, okay, we'll replace that part on a regular interval. There's a lot of trouble with that, and I'll share more of the reasons why in just a few minutes. In fact, what we see is somewhere around 30% of the preventive maintenance tasks that exist in most facilities today are completely non-value added. So if you think about that, if you take the time to start reviewing those preventive maintenance tasks, removing that waste, you can free up a lot of resources that can then focus on many of the other things. Now the TA downtime is technology underutilization. Not using your CMMS, not using the predictive maintenance tools, all of those things give us efficiency, but it also gives us transparency into those assets. The I in downtime is inventory overages and slow movers. Now I know none of you guys have whole storerooms full of assets so that you never have any downtime, but this, obviously if we have reliability issues or maintenance issues, if we're not at a very high mature state, you're going to have to carry a lot more of that inventory for those emergency issues. Material defects, the M in downtime. Now we're talking about how we store those parts, how we store in-process goods. All of those can lead to the defects that get into our system. How many of you have had a bearing that someone took out of the grease paper and then put back on the shelf in the storeroom? Then when you go to get it and use it later on, you notice their fingerprint on that asset. So that's a material defect. We install that into the piece of equipment. There's a pretty good chance we're going to have problems out of it at a much faster rate than what we would have if it had been in like-new condition. The E in the downtime acronym is errors in process, people, and procedures. And here we're talking about, do we have good procedures? Do they have the detail that we need? Have people been task qualified on those procedures? And do we have a process to drive people through those procedures moving forward? So that's the downtime, or 8 areas of waste in lean, maintenance, and reliability. Now we'll move on to the next slide. So let's talk a little bit about 5S. 5S is broken out into 5 S words, originally from the Japanese, but we have converted them over here in the U.S., and I'm going to show you each of those over the next few seconds. So the first one is searing, and that is sort, and this has to do with tidiness or organizing the workplace. In other words, getting rid of those things that are unnecessary. Seitan, or straighten, also orderliness. This is all about how a systematic manner that will encourage efficiency and reduce unnecessary travel and motion. And I'll show you an example of that in a few minutes. Seiso, or shine, also scrub, I've seen in some facilities here in the U.S., and now we're getting into that cleanliness piece. We're getting into making sure that if we take the machine to that clean level, we can identify defects very quickly. Very core to doing good maintenance. I mean, if you have oil leaking everywhere and the equipment's covered with dust and dirt that's sticking to that oil, then it's very hard for you to see the source of that leak. It's very hard to identify new issues or new defects that are getting introduced to the system. So this is all about cleaning away the debris so that we can really understand how that asset performs. The next one we have is Sakisu, and that is around standardize. And here we're actually making sure that there is a standard for cleanliness. So no matter where I come from in the organization, it becomes very apparent to me what is expected in each of these areas. And the last one that I'll show you today, Chisaki, and that is systematize or sustain. And here we're talking about how do we drive this into the culture? How do we create that discipline? How do we just make this the way we do business day in and day out? So those are the 5 S's. You may have a little bit different within your facility. I do see a little variation from one point to another. But what I want to do is now take this 5S and really apply it to the maintenance and reliability engineering side of the house. Before I do that, though, I'm going to move into the 5S number game. So we'll move forward one slide here. And what I'm going to ask you to do is put in place or put in practice what I just described. So I'm going to give you an exercise. We'll move forward to the without 5S slide. And what I'm going to do is I'm going to give you 15 seconds. So in the next 15 seconds, I would like for you to see, starting from 1, how high you can count on the numbers on the screen. And start now. Okay, you should be wrapping up. So I've given you 15 seconds. You've taken the time to count. Now you'll notice these numbers have not been 5S. They have not been through the 5 steps that we talked about a few minutes ago. So let's take a look at what happens as we move through. We'll go to the next slide. We've moved into the sort step. We've removed what was not needed. So what I'm going to go ahead and do is I'm going to give you, again, 15 seconds. In this 15 seconds, I would like for you to try to count the numbers from 1 to 30. Starting now. Okay, so I'm hoping you were able to get a little bit quicker this time. You were able to count a little higher than you maybe did in the last exercise. So what we're going to do is we're going to move into the next 5S step. Now in this step, we've simplified or we've organized these numbers. So again, I'll give you that same 15 seconds. Let's see how you do. Let's see how high you can go on that 1 to 30 count. Starting now. Okay, I hope in that 15 seconds you were able to get a little closer to that magic number. All right, and now we're going to move into the next stage of the 5S process, and we're going to move to the next slide and talk about standardize. So I've put them in order. Now you can easily count the numbers in the 15 seconds, starting now. Okay, so you can see the standardize. Again, it gets easier every time as you move through these because we're putting more of that order that 5S brings to the workplace. Now the last one we're going to look at is sustain. We'll go to the next slide. So in the sustain section, I won't make you go through and do this one, but I think you can see very quickly that something's missing. And this is one of the elements that you see from a 5S standpoint. Because we've got a process, because we've got organization, because we've removed all those unnecessary items, it now becomes very easy to see when there's an issue. So let's talk about 5S. Of course, we can use that on the production floor, but how might we use that from a maintenance and reliability standpoint? So think about that for just a second. Where might you apply it? And then I'll share a few of my ideas with you. Okay, so what I'm going to do is I'm going to tell you one example, and I think, anytime you have maintenance crafts and they're working in an area, of course we can use 5S to improve those areas. But one area that I found even more interesting was that I could take 5S and apply it to my preventive maintenance program, and I'm going to show you guys that on the next slide. So what I've done is I've given you a comparison of 5S and what we call the PM evaluation stage, and you'll see both of those compared here on the screen. So again, I've shown each of the steps of 5S. I've given you the terms that match up to each of those, and then I've given what you might do to evaluate or improve your preventive maintenance task. So for the first one, separate. We can eliminate all non-value-added tasks from the PM. In other words, remove those tasks that maybe don't have a true root cause basis. They may be symptoms of root causes. So as we figure out what the actual root cause is, we can then focus on that root cause and remove all those non-value-added tasks. Now the second one you see is straighten. We can reassign those appropriate tasks to operations or lubrication routes. And what I mean here is now we're looking at those tasks and saying, okay, operations is already walking around that piece of equipment on a daily basis. Are there things here that would be better served for them to do during the normal time that they're already walking around? And we're not talking about adding additional work here. If they're walking past a gauge and we can take the time to color code that gauge, very quickly they can take a look and see, is it within spec? And if it's not, then they would issue a work order through the CMMS or the EAM. This then takes that step away from the maintenance craftsman who may be coming all the way from another part of the facility just to check that gauge as part of a PM. Now the next one you see is scrub. And in the scrub section, we're going to eliminate all the tasks that do not specifically address a failure mode. So we'll talk a little bit about RCM a little later, but RCM, one of the key components of that is going through and doing a failure mode defects analysis. In other words, looking at how an asset might fail. And if I understand how it will fail, I can get to those specific failure modes, and then I can see if my PMs actually line up to address those failure modes. If they don't, they're probably non-value added tasks, and we need to revisit those. And if they do, we need to make sure it's clear within that task how best to make sure that we check for that specific failure mode. Now the next one you see is standardized. And here we're going to ensure all the remaining tasks follow a standardized format. There's clear definitions, there's specific steps, there's necessary safety warnings, what tools I might need, what required parts might be required as we move forward. So here now we've standardized what work looks like. So when someone gets one of these preventive maintenance tasks, they know exactly where to find the details that they need. And I'm not suggesting that every one of the PM tasks has to look like a training document. But it definitely does need to call out things like torque specs. It may need to call out belt tensions, alignment standards, all of those sort of things that might become part of that PM that I probably don't devote those standards to my mind. So I want to make sure those are included in that PM task. Now the last one, systematize. And in here, we're going to make sure all the tasks are quantifiable in nature, and they have specific measurable activities. So instead of asking someone just to check the pump, now we're going to, based on the previous step, standardize that and now tell them exactly what specific failure modes they need to look for that pump, and then try our best to make those quantitative. So instead of saying, is the belt frayed, to what degree is it frayed? To what degree is it cracked? To begin to give us more information so that we can better understand those assets. So that is a comparison of 5S and a PM evaluation process. Again, we're using those same tools that came from the Toyota production system that became what we call lean today, but we're using it in the maintenance realm to explain how we can improve our process. We're going to move on to the next slide. And this is how that looks for us. So we're taking those individual PM tasks. We're breaking them down into their components. We're looking at the total amount of hours associated to each of those. We're going to eliminate those non-value-added activities. We're going to reassign the tasks that we can to operations. And we're going to reassign maybe to lubrication routes or others to begin to get more efficiency in our process. Now, if we move on to the next slide, what you're going to see is the results of one of those studies. And this would give you an idea of how things might be within your facility. So we've taken 5S, we've applied it to our PMs within our process, and here's the results. In this facility, 8.2% were absolutely non-value added, meaning they had no value whatsoever. They didn't address a failure mode. They didn't do anything that made us more reliable moving forward. We also were able to move 6.9% over to the operator care route. You can see the amount of hours that represents. And then we also moved 14.3% over to lubrication routes. Now we can task qualify individuals to attack those lubrication routes. They can move through the facility much more efficiently. They know what they're looking for. They know that grease is not grease and oil is not oil, and you can't mix the two. They're making sure they keep our oil clean, keeping our grease fresh, making sure that we beat those shelf lives on all of those. So all of those best practices can be handled by the lubrication team. Now you see 32% of the PM task in this facility needed to be replaced with PDM. So the great thing about using the predictive technologies like PDM, is that, and just in case everyone's not familiar with the predictive tools, let me list those for you. So the big five that we talk about: vibration, infrared, oil analysis. We also talk about motor current analysis and ultrasonic. So those are some tools that we might use to really begin to see defects at the early stages. The great thing about those tools is they're used while the equipment is running in many cases. In fact, in most cases, all with the exception of maybe MCA offline. So in doing that, by going through that process, we're getting the data, we're identifying the defects, but we're doing it without downtime. Of course, that's a big deal for operations, because now, in the current state, when you do an invasive PM, you're taking that piece of equipment down, you possibly are taking it apart, you could be introducing infant mortality issues to it as you go through that process. So by using these predictive tools, we're able to take a look into that asset, identify those defects, understand that asset health, and do all of that while the equipment is still running. So you see 32% of their tasks needed to be moved over to a predictive maintenance task, and many of those can be done in less time with a PDM tool. About 26% needed to be re-engineered in that facility. And what we mean by re-engineering is, and you see these all the time, it's not that it's a bad task, it just doesn't have enough detail. It may say, check the pump, check the motor, check the gearbox, check the belts. But what am I checking it for? And it goes back to our conversation a few minutes ago. What failure modes specifically am I looking for in each of those areas? And then in this facility, about 10% of the items had no modification required, meaning that that task was failure mode based, it was quantitative, it was easily applied to multiple areas, it was standardized, and everyone was doing it the same way. So if you start looking at that, you realize you could free up a pretty substantial amount of man hours just by going through that process, just by using 5S on your PM program. Now you may use those man hours to attack your backlog, your work backlog within the facility. You may use them to help write or rewrite some of these PMs, or possibly develop RCM analysis of various pieces of equipment or new equipment that's coming in. So this could be really powerful, because all of us have the struggles of not having enough resources to do everything that we need to do. All right, we'll move on to the next slide. So in the next slide, we're looking at MUDA. And MUDA is this idea of overproduction. It's making more than what we need. And that's the lean definition. But what I'm going to do is I'm going to talk about the reliability application today. So the reliability application is this idea of over-maintenance. So how many pieces of equipment within your facility are you really just doing too much to? And there are many issues that come with that. Not only is it the parts associated with doing too much maintenance, it's the invasive maintenance that you're doing that might bring in infant mortality. It's also the fact that you're having to take that equipment out of service to do that maintenance. So there's a lot of waste associated with this idea of maintenance overproduction. So to eliminate that, develop a deeper understanding of the true nature of those equipment failures, and go back to the previous slides that we just talked about, and really refine those PM tasks that you're doing and eliminate that over-maintenance component. So you should have good maintenance strategies for each of your assets, and I hope that's something you guys are looking at on a regular basis. If you have reliability engineers or maintenance engineers, they may be helping you as well, working with your planners and schedulers to really make sure that those maintenance strategies don't include this idea or this concept of over-maintenance. We'll move on to the next slide, and this is MUDA number 2, and we're looking at transportation. So in the lean definition, this is moving products further than is minimally required. From a reliability standpoint, this may look like excessive side trips by crafts. You know, how many times do you send someone in the field to do work, and they get there and realize they don't have the appropriate tools? They don't have the parts that they need. They may not have the forms that they need to make that job effective. So they start traveling back and forth. And as you guys all know, I mean, when you send somebody across the facility, they're going to get distracted. They're going to get pulled into other issues. So at the end of the day, now we've got a lot of travel back and forth and a lot of distraction getting introduced to our process, further eroding that idea of wrench time, or the time that we're getting work done within the facility. So if we can improve our job plans and create good job plan procedures that have all those details, make sure that we have good bill of materials so that when we go to do the job, we have the parts that we needed from a kitted process. And kitted is all about taking specifically from the storeroom, the parts that I need to execute the job, putting them in a crate or a storage area so that when they get to that job, they don't have to go back and forth to that storeroom. So we're reducing those excessive side trips and further eliminating more waste or muda from our system. Now we're going to go on to the next slide, and we're going to talk about waiting. This is muda number 3. And the lean definition here is products waiting on the next production step or people waiting to do work. And, you know, for maintenance and reliability, we see a lot of this. We see people waiting to do work on the assets. So if you've got maybe not a good scheduling process or you don't have good communication between your maintenance and operations folks, that's where you see this type of waste coming into play. If you've got 3 or 4 maintenance guys that arrive to a piece of equipment, the equipment hasn't been shut down, hasn't been cleaned, it's not ready for that maintenance work, they could be standing there 30 minutes or longer. And when you think about that, 30 minutes times 2, 3, maybe even 4 maintenance crafts, that adds up to a lot of lost productivity, a lot of waste. So that's muda number 3. Now we'll move on to number 4. Number 4 is inventory. And the lean definition here is having more inventory than is minimally required, excess inventory. And from an operations or from a maintenance standpoint, here, this can be all of those parts that we have because we're living in a reactive environment. You know, if you're living in a reactive environment, what you really want from the storeroom is a perfect copy of your asset only on the shelf and ready to go. At that point, if anything fails, you run to that storeroom as a firefighter, you grab the part you need, and you run back and everybody pats you on the back. But in reality, think about all the money that's tied up in all that inventory sitting there on the shelves. You know, it really pulls on the organization because that's capital, that's cash that they can be using to invest in new assets, new technology, all kinds of things that would better the business, but it's tied up sitting in there with dust all over it in those storerooms. So that's the inventory waste that we're talking about when we talk about muda number 4. So what do? You start to try to detect those defects earlier. And again, I'll reach back to predictive maintenance because I think it's so crucial to this idea of lean maintenance moving forward because predictive maintenance buys us time. And I'll show you a little more about that in a few slides. But the whole idea here is if I'm using a predictive technology, I'm identifying that defect very early on what we call the P to F curve, which I'll show you shortly. And by doing that, that gives us the time to both plan and schedule the work, but also get those parts from an outside vendor. So when we get those parts from an outside vendor, they're sitting on their inventory, not ours, and they're not tying up our capital. So now we'll move on to the next slide where we'll talk about muda number 5. Muda number 5 is motion. And in the lean definition, this is people moving or walking more than is minimally required. And some of the things that I think about, and I mentioned them a few minutes ago, for us in the maintenance and reliability world, this is poor wrench time. It's excessive troubleshooting. It's poor craft skills that create rework. Maybe someone's not familiar, and I worked in a facility years ago where there was a lot of really good people, and they really wanted to be successful at their job, but unfortunately, they really hadn't learned a lot of the newer techniques. They hadn't really been trained on anything new in quite some time. So a lot of the work that they were doing was actually introducing defects into the facility. One in particular that comes to mind for me, they had belts within that facility, and no one had ever taught them that you could take a belt or a shiv gauge and put it into the pulley and see if it was bad. So in reality, there were quite a few failed pulleys within that facility. And so by doing that, they were putting the belts on and they were tightening the belts excessively so that they wouldn't slip. So we had 2 problems. We had worn out pulleys. We had excessive tension on the belts. So between the 2 of them, we were losing belts because they weren't being used the way they were expected to be used. We were destroying bearings because they were overloaded. And of course, all of that was leading to this excessive motion back and forth to the equipment to make these repairs. So if we can improve our planning, if we can have better inspection methods, if we can improve our craft skills, we can eliminate that motion back and forth and again take some of that waste out of the system. We'll move on to the next area, which is work sampling. And what I want to show you guys is just a little bit of a sample of what you might see in facilities today. This This doesn't represent the average client that I see, but it does represent the average client in North America. So if you look, I'm not going to go through all the areas with you today, but you see a few key points. The active repair time. Now in here we're talking about 35%. That means that that mechanic is out there using his tools, using the trade, using what he does 35% of his day. My average client, probably closer to 20, but of course they don't call me unless they have a problem. So from that standpoint, when I'm getting involved many times, they're not practicing best practice. They're not planning and scheduling, so their active repair time is a little lower. You might think a little bit about yours and see where it falls out. But what's interesting when you look at this, if your active repair time is somewhere around 35%, and best practice is somewhere around 50, 60, maybe even as much as 65%, depending on how you calculate it, what you begin to see is if I can improve and remove the waste from this work sampling chart here, or at least reduce the waste within this, it frees up a lot of man hours. It could even lead to doubling the throughput of your workforce. So, a few ways to address this. A lot of folks do time studies. I'm not a big fan of walking around with a stopwatch. It tends to make people a little nervous. But one thing that I like to do is just a simple day in the life of, or a dialo. And the idea here is not to go out and spend a whole lot of time looking over their shoulder and trying to find what they're doing wrong or where they're wasting time or where they may have taken a few minutes extra on their break. That's really not what we're after here. What we want to do is start to understand what is getting in their way. So if that craftsman, that electrician, that mechanic is out there working, what are the issues that are taking away from that repair time? What I find many times is if I just start addressing those, I can make a huge step change in the way we use wrench time or the amount of wrench time that we get from each of those individuals. And it also is a morale booster for them. At first, they're gonna be a little curious about you, why you're there, what you're doing. Let them know that you really just want them to point out what's bad, what's good, what gets in your way, what keeps you from being successful day in and day out. As you go through that time, you can jot down a few notes, jot down a few issues or a few points about how long or what waste you might have. And a lot of that you can just use to justify the solutions you're going to put into play. But if you go through that exercise, I promise you'll find many, many areas that can improve that active repair time. We'll move on to the next slide. So on this slide, I've listed a few more activities. I'll let you take just a few minutes to read through that. A little bit about whether they're internal or external, maybe even both, and then what you might do to improve them. So these are kind of some takeaways that you might be able to use. I'll give you about 10 seconds to read through this. Okay, so you may have seen a few things in there, maybe a few areas that you would like to work on. It could be active repair time or anything around idle time at the jobs. And then over there in your change and improve, you can look at some things you might address to make those better. I think one of the big things that you can always focus on is this idea of processes. We'll talk a little more about processes a little later, but when you put a process in place and everyone's doing it the same way, you can really start to see the waste that is generated, and then we can start to eliminate it and make it better going forward. So we'll move on to the next slide, and that's going to be move to number 6, and that's the processing itself. So standalone processes from a lean definition standpoint, standalone processes that are not linked to the upstream or downstream processes. They're not combined tasks. To simplify the process, we may have multiple steps or multiple people doing things that could all be done by one individual, making it much more efficient. Or it's just the fact that we're processing too much, or it's just not, we could simplify the process and make it so much cleaner and more efficient. Now, from a maintenance and reliability standpoint, I have to go after the standard work process. How do you get work done within your facility? You know, when there's a repair that needs to be done in the facility, what's the first step? Where do I go? How do I get that work approved? How do I get it planned? How do I get it scheduled? How do I make sure that it's standardized and everyone's doing it the same way? Because one of the issues that I see in many facilities when I go through this process is that their processes are convoluted. There are multiple ways to get things done. There are multiple paths through the process. You know, for instance, I don't really like getting my work approved in my area, so I'll go talk to this individual over here that I play golf with on the weekends. I'll just see if he can come over here and take care of this for me real quickly. Now, by doing that, I've avoided having to fill out a work order. I've avoided the work approval process. I've pulled him in, taking him off of what he should have been doing and pulling him into what may even not be an emergent repair, just so that I meet my needs. In doing that, of course, I've created a lot of waste. So that's one of the areas that I think about as I move through this. Another area, as an operations person, maybe I'll put in a work request, and that work request goes into the process. But because there's not a good standard streamlined process, I get to that step and it gets closed out. The work order gets closed out. Now, there's a legitimate reason why we closed out that work order. Maybe we're not making that repair because we know that a new unit is coming in soon, or we've got some budgetary issues, or whatever the case may be. But no one has communicated back to that work requester and let him know what the issues were or why it was closed. So he may put that same work request in again the next week. He may even do it a third week, but after that, chances of you getting anything from him are probably fairly slim. So you start to lose one of the most important things on the shop floor, and that is the input from the operations folks who are out there operating that equipment day in and day out. So what I'd like to do is move on to the next area, which is moving number 7, the defects. And in the defects here, we're talking about from a lean standpoint. This is the effort involved with inspecting or eliminating the defects. So if we can start to use in our maintenance process, use tools that allow us either not to create those defects or identify them as early as possible, that'll allow us to eliminate those defects going forward. Now we'll move on to kind of how those defects get introduced, and I'll take you through this here very quickly. So if you look here, this is a great graphic, originally put out by Ron Moore, and you can find it in his book as well. But he's showing, as an asset is created, all the different levels and where those defects are introduced. Now today I'll just point out 3 areas here. We've got defects in design, we've got defects in install and startup, and defects in operate. You notice those are a little higher than the other areas. So a little takeaway for you, a little something to think about. If you're like many of the facilities in the world, what you're going to see is that many of the defects you're dealing with are because of design, install and startup, and operate. So if you begin to look at those can be key areas that you can eliminate the defects and eliminate the waste. I'm going to take us into the P to F curve, and this is the next slide. So you can begin to see, I talked about if we can identify these issues early, could be through predictive maintenance or in any one of the predictive tools. It gives us that time to make that repair. And this graphic here, what I want to show is simply that if I can identify it early, the cost of repair is going to be substantially lower. If I'm going to wait till the very end or wait till I hear it or wait till I smell it or wait till I see it, then we're going to be very close to that failure, and at that point that cost of that repair is probably going to be emergent, and emergent repairs typically will be about 5 times as expensive as a good, solid, planned and scheduled process or repair moving forward. Now the next one is move to number 8, so we're moving on to the next slide here, and this is safety. And, you know, from a lean standpoint, unsafe work areas create lost work hours and expense. And it's really no different from a maintenance and reliability standpoint. If we're running around chasing and firefighting and living in that reactive world, we are not going to be as safe as we need to be. We're not going to be able to take the time to look at all the risk associated with each of them. And I'll show that to you in the next slide. And I'm going to look at overall equipment effectiveness in this next slide. And you'll see how it actually flows back and forth. So if you look at the red line here, the red line is their safety rate from a real facility. This comes from Ron Moore's Making Common Sense Common Practice. And as you improve their safety rate, or as that safety rate improved, you'll also note that their OEE went up. Now, I would say it works exactly the opposite. The simple fact is they improved the reliability of their assets. By improving the reliability of their assets, which led to higher overall equipment effectiveness, they were making less emergent repairs, they were planning and scheduling more jobs, and they removed a lot of that safety risk. So you can begin to see that in that graphic. It's pretty obvious as you look through that, pretty impressive. And Ron does a little more of an expansion on it in his book, and I definitely would recommend you guys check that out. So the last area, move to number 9, is information. And in here, they're referring to how we use information. This could be in the ERP or the Enterprise Resource Planning module that you're using. This could be SAP, Oracle, SAP or Oracle, or possibly some of the others. But what we're going to do is we're going to look at it from a maintenance standpoint. So in the maintenance and reliability, when we look at the maintenance for us, what we see is, do we have good information collected on configuration of the components? Do we have labor and materials stored in our EAM or our CMMS? So are we making good use of all the information that we have? Or are we making repairs on a regular basis, not collecting that information, and at some point spending more on that maintenance than we ought to moving forward? So the next slide we're going to look at is Kaizen. And Kaizen, really the point I want you to take away from this piece today, that it's all about an attitude. Kaizen is not an event. We talk about Kaizen events. You see that a lot from a lean maintenance standpoint. And while it does give us that focus, it does allow us to go in and really look at those assets, put focus on them, repair and make changes, improve the process. But if we just walk away from it at the end of that week and no one pays any attention to it, I promise you it'll move right back to where it was. I've seen this over and over in industry. So the whole idea behind Kaizen is this idea of continuous improvement, working continuously to make small changes that will give us big changes in the end. We'll move on to the next slide. And what I want to do now is kind of take all of the things that we've talked about today and tie it back together. So I talked a little bit about some of the solutions, things like looking at your processes, some of the different types of waste. But what are you going to do with it when you get back to your facility? How are you going to take what you heard today in this webinar and make a change? So what I'm going to do is I'm going to say that this graphic here, this page, gives you a process. It gives you a checklist to go through when you finish today and start thinking about what you can do in your facility differently. So one of the things you might do is look at your processes. Try to understand where you might have waste in there. Those processes touch so many people on a regular basis. If you can make improvements in that step, you're going to be helping a lot of people be more efficient, more effective, and more lean moving forward. Then we want to focus on identifying waste. So once we know what our processes are, we know what our procedures are, now we can start looking where we might have that MUDA or non-value-added activity. The next thing that we have is converting that waste over to the value-added work. In other words, making sure that we're going through eliminating the waste and really building in value-added steps along the way. Now we want to document those new processes because we can have great new processes, but if we don't get them documented and get them communicated out for the organization, get folks task qualified to use those new processes, then in reality we haven't changed anything and there's no real return on investment. Then go back to that process that we talked about called Kaizen, that continuously improving. So when you get that new process in place, now you want to continue to tweak on it over and over, aggressively. In fact, I would say if you're not using the concept of Kaizen, you're probably falling backwards on a day-to-day basis. Now the last piece that you're going to want to do is this idea of monitoring progress. And in this piece, what we're doing is we're using metrics, and we're going back to those processes that we changed. For every point that there's a change from the old way of doing business to the new way, we probably ought to put a metric in place to understand when we've ingrained that into the way we do business. Now don't overdo it. We can't have metrics for everything, but what we're going to be able to do is wrap those up and focus on the key behaviors that we want to change, and in the end that'll get us step by step continuously to that new state of doing business. So that's what I had for you today. I'm going to move on to my last slide here and just thank you for spending the hour with me today, learning a little bit about maintenance and reliability and how that ties into lean and how the tools are exactly the same. We just apply them within our world. Hope you enjoy it. If you have any questions, please feel free to reach out to me. My cell phone number is 843-810-4446. And again, you can also check out my blog or reach me there at any time at reliabilitynow.com. Hope you guys have a great day.
Thanks, Sean. Great presentation, and we wanted this to be a comprehensive view of the topic of lean, so we're going to take all of our questions offline today and make sure that Sean and I get back to you with all the responses. You'll be able to see that online, and we'll be responding to our questionnaires. So if you've got a question from today's presentation, type it into the Ask a Question box on your screen. We'll make sure that Sean gets those, and we'll be responding to those. Will be answered as part of this webcast package posted at planengineering.com and also appear in the April issue of Plant Engineering magazine. So we want you to take a look at our report on this lean manufacturing and lean maintenance webcast today, and you'll be able to see that in the Plant Engineering. We'll also have the on-demand presentation of today's webcast. We'll send you an email when it's ready. You'll be able to access that webcast via the Plant Engineering homepage, also at plantengineering.com. I'd like to close today by thanking Sean Eisenhower for his time and expertise.